What do rapeseed, sugar beets and corn have in common? They can feed you or put petrol in your car. Rising oil prices and the fact that fossil fuels are running out have dramatically bumped up the demand for renewables, especially biomass. In Germany, biomass currently accounts for 8% of all energy produced. As a result, crops are being diverted away from producing food to generating fuel instead. Critics say this is fueling world hunger. But does it really have to be a question about food or fuel? Scientists in Germany think that there is a way around this competition. They're taking a good look at potential energy crops.
This unmanned flying device is spying for science. Scientists at the Jülich Research Center use the little remote sensing drone to assist their research on plants. They've been growing new types of energy crops on their test field. The bird's eye view provides the best vantage point for judging which crop will generate the most biomass for making fuel. It's an elegant surveillance method, especially when the weather plays along.
It's always fun to watch it and to see the pictures afterwards. But the really exciting thing for us is the data we get from these images.
One of the bigger research projects at Jülich is the future of the world's energy supplies. That includes plants that can be turned into biofuel. Which crops are best, which ones grow fastest and most uniformly.
These pictures from above are fairly unusual. Outdoors, I generally have the familiar aspect of a normal field, but from above, I get a completely different view of the homogeneity of this crop.
Images taken at different wavelengths show the scientists how efficiently the plant's photosynthesis is working, which nutrients they need, and how fast they grow. The challenge is to find a way to grow energy plants without occupying fields that are needed to grow food crops. Species like the North American cup plant could help put an end to the competition between fuel and food.
With these plants, we're trying to avoid that conflict, because with these plants, we can go on to marginal soils, poor soils that are not suitable for food production.
Here in their greenhouse, the researchers test the growth under laboratory conditions. They can check 500 plants a day in the fully automated facility. The aim is to find varieties with the highest yield and the greatest resistance and breed them as energy crops. An important indicator is root growth. A specially developed CT scanner shows this clearly. Energy plants need strong roots because after the harvest, they have to grow back quickly. Ulrich Schur has built up a network of research institutes and universities. The goal is to integrate basic research results into agricultural practice. The scientists believe modern plant research has a huge potential for the future, and they're optimistic about the possibility of replacing fossil fuel with biofuel, without making more people go hungry.
In the future, there'll be a whole series of plant species that we can use. Energy crops, food crops. We'll have a great diversity of different plants. There isn't going to be just the one plant that can do it all, but we'll have different plants for different applications.
In that vision, common grain plants would no longer be used for energy. At most, the waste left over after harvesting food crops could be processed into fuel. Even straw can be used to produce fuel, either as an additive for gasoline or as pure bioethanol. The scientists at Jülich are especially interested in energy crops that grow on poor soils. That way, they can ensure that valuable acreage for food plants won't be sacrificed. Energy from the field. The German government also sees a big future for the concept. and is pouring generous funding into research in this area.
So, is biomass the energy source of the future? Well, as we just heard, those scientists in Jülich are very optimistic, but some experts take a more sober view. Joining us in the studio is Professor Bernhard Schinck, a microbiologist from the University of Konstanz. Professor Schinck, thank you very much for joining us here at Tomorrow Today. Now, you yourself are a co-author of a study that's actually carried out for the German National Academy of Sciences, the Leopoldina, and the report is called Bioenergy, Chances and Limits. Now, we've seen some of the chances in this report. What about the limits?
Well, we have to realize that the efficiency of energy transformation by green plants is very limited. Of the sun irradiation that reaches the plant, only 1% is converted into biomass. And the further treatment of the biomass into energy carriers leads to further losses. On the other hand, if you think of, for instance, photovoltaics, which has efficiencies in the range of 15%, then the biomass production is by at least one order of magnitude off. So even if we could slightly increase the productivity of plants, as suggested in this program, it will still be far away from what other techniques can really yield.
Okay, energy from biomass might not compare to, for example, photovoltaics, but, for example, it has some advantages.
For sure. So bioenergy has the advantage that it can be stored, and it can definitively contribute a part to our energy needs. If, for instance, waste materials, leftovers in agriculture and so on are being used as feed for bioreactors. But with that, we are somewhere in the range of perhaps 5% of our energy needs that we can cover this way. Everything beyond that is not really on a long-term perspective bearable for the environment, since whenever we carry out intensive agriculture, we also use fertilizers and so on, which contribute to greenhouse gas production.
Of course. Now, your own report has actually made recommendations to policymakers. What was the most important piece of advice that you could give them?
Our main message was not to increase biomass production any further for energy needs, rather to concentrate on waste and leftover materials. And, of course, as well to save energy and cut down on our energy needs. That is a very important area.
But despite that, biomass still looks set to stay. What about, in your opinion, what is the most efficient way to use it?
The most efficient technology to use biomass is the formation of biogas rather than biodiesel or bioethanol. Because the biogas production already covers the entire plant material rather than only the starchy parts of the plants that can be used for ethanol production, for instance. So there the efficiency is substantially higher and the technology is there. It's easy.
Professor Schinck, thank you so much for joining us here at Tomorrow Today.